stove or clay stove, or improved cook stove such as rocket, wood stove, or gasifier. Such technologies generally use traditional fuel such as firewood or charcoal. It is possible also to use modern energy stoves such as gas stove, liquid stove, and electric stove. But the problem is always the access to energy. In order to exploit the sun, such as renewable energy, it is possible to use additional cooking technologies, such as solar cookers or fireless cooker, which allow to reduce the emission and also reduce the time spent for fuel collection. Of course, the problem of such technologies is they increase the time for cooking. Let's go more in deep in such kind of technologies that can be divided in three main categories. The box cooker, that is this one that you can see in the picture, that consists of an insulated box covered with a transparent glass and endowed with reflective surfaces. They can be easily homemade with waste metal, glass, and corrugated paper or wood. These simple models are slow to heat up because they do not concentrate the rays on the pot, and they hardly bring the water to boil, taking too much hours. The cost in general is between $1 and $5, so it's very cheap. The second technology is the panel cooker, which is the most common type of solar cooker adopted, thanks to the ease and low cost of construction that is in between $5 and $20. They use a reflective surface to collect, concentrate, and direct the sun rays onto the pot, which can be enclosed in a transparent plastic bag in order to create the greenhouse effect and maintain the heat inside. On average, during sunny days, 300 grams of beans in 400 milliliters of water can be cooked in less than an hour. Finally, the parabolic cooker consists of a simple parabolic reflector in which the pot is located on the pot point, thanks to a stand system to support it. The solar cooker can generate over 2,000 watt of power, boiling on average 5 liters of water in almost 70 minutes. It is much expensive than other technologies, and the cost is almost $100. Such technologies should be adopted in a location with high amount of solar radiation. In the map, the place characterized by darker color. Another very interesting technology is represented by hay basket, which is a simple container where partially cooked food can be stored in order to continue cooking with no need to consume further fuel. This is useful in context with limited access to fuel, particularly for food requiring a long cooking time, such as legumes and rice. For example, a pot of rice can be initially to boil with a traditional stove, and then placed in a basket to complete the cooking without burning any further fuel. It allows to reduce the fuel use by even 40%. Obviously, the length of cooking time is higher compared with a traditional stove. In general, the hay basket requires 2 times the normal cooking time of a fueled stove. This is an image of the hay basket. Let's go to technologies for food preservation. The preservation consists in increasing the shelf of life of food and products, but also it consists in preserve food from animals, bacteria, and contaminants. Several methods exist in order to preserve food, such as drying or using chemicals such as salting, nitrates, and nitrates, or heat treatment processing, packaging, or refrigeration and freezing. Of course, among that the most effective technologies is the refrigeration and freezing. However, both require constant access to electrical energy. Moreover, freezing changes the physical state and also the flavor of food. In order to exploit the renewable source, solar drying and evaporative refrigeration can be used. More in detail, solar drying enhances the dehydration of fresh food with a simple greenhouse effect. The simplest model can be homemade, built with few dollars. Here you can see an image of such technology. The evaporative refrigeration that generally consists in the realization of their pot, which consists of 2 covered pots of different diameters, one placed inside the other. The space between the pot is filled with wet sand that is kept constantly moist. Food to be preserved is put in the smaller inner pot, which is covered and left in a very dry and ventilated place. The water contained in the sand between the 2 pots evaporates towards the outer surface of the larger pot, where the dry outside air is circulating. The evaporation process causes a drop in temperature of several degrees, cooling the inner pot and extending the shelf of life of food inside. Of course, such technology is useful in context characterized by very dry climates. Here you can see an image of a depot realized in Niger. Something about access to clean water and to water treatment. In a humanitarian context, in fact, generally the need for clean water is usually immediate. Therefore, providing systems that purify water and contribute to guarantee the minimum standard for water quality is pivotal. Now I would like to show 2 different technologies. The first one is called solar water disinfection, or SODIS, while the second one consists in a filtration of water. The SODIS system can be easily realized by putting a transparent bottle of water under the sunrise. It removes pathogens from water by combination of UV rays and high temperature of water. Of course, filtration is mandatory, and a time between 6 hours and 2 days in case of intermittent sun, of course, are required. The second technology already available also in the market is the membrane filter, which are based on the presence of semi-permeable membranes that work following such principle. The membrane acts as a very specific filter through which the water flows, while suspended solid and other substances remain catch. This system is able to remove biological contaminants from larger bacteria to virus, and moreover does not require the use of external energy. Here you can see an image of the first system and also of the second. Here you can hear me?
Yes, now I can. Yes.
Please, can you switch off the microphone? Okay, go ahead. Instead for food, we developed several tools. Some of that is already available online, such as the Set for Food guideline and the Set for Food decision support system. The guideline provides the user with a list of possible needs and corresponding energy solutions for food utilization, which have been grouped within the following categories: cooking, preservation, water pumping, and water treatment, and finally integrated renewable energy system for providing local and reliable electricity. Such guideline is available online in the website of Set for Food. In order to provide valuable support for the choice of the most appropriate technologies, the technological system in the guideline are described in specific technical sheets, which give information about the main technological characteristics, as well as indication about local construction, warning, and specific requirements, operation and maintenance, and an indication of the cost of the technologies. Summary tables provide the pros and the cons by comparing the different options to help identify the most appropriate technology for each area of intervention. The second tools that we developed in Set for Food is the decision support system, which is an online tools which is mainly addressed to local staff operating in a humanitarian context. The tools allow a preliminary selection of the most appropriate technologies for food preparation and preservation and other related issues, such as electricity for lighting, according to a number of parameters, for instance, location, available resources, and other information from the local context. the information, the DSS is gathered in 5 main issues, which is the technologies for food preservation, for food cooking, for water treatment, for power generation, and finally for water pumping. Thank you. Now my colleague Lorenzo Mattarolo gives to you some information and deeply description of the impact evaluation framework. If you have some questions about this lecture, you can do it now. Maybe by chat. Semira, let me know.
Thank you, Fabrizio. Let's give it one more second so that people can have a chance to ask questions or make comments.
Of course.
Thank you. Okay, I don't see any hands raised or any comments written. So I'll give the word to Lorenzo so that if others have questions or comments, please, I'll invite you to do it during chat or by raising your hand. Thank you. Please go ahead, Lorenzo.